Hello. In this video, I want to explain the difference between a population and a random sample taken from that population, and also discuss with you 4 different ways of taking a random sample. So in statistics, when there is a group, a topic, a subject that we want to study, that we want to collect data from, we call that entire group the population. Now, it is almost always impossible to survey every member or part of a population. It would take too much time and cost too much money. In the United States, the only time we actually survey the entire population is when we take the census. And as you know, that's only done every 10 years. So what do we do? Well, we go into this population, and from this population, we want to select a sample. So the sample is taken from the population, but it's so important that the sample is random. And what that means is this, that every member of the population has the same chance to be selected for the sample. If that doesn't happen, if every member does not have the same chance to be selected, then our sample is biased, and the results from a biased sample must be discarded. They're basically worthless. And the best example of that is the presidential election in 1948, when CBS News picked up the phone and called people and said, "Hey, who are you going to vote for?" And overwhelmingly, the people said, "We're going to vote for Dewey." But when the vote was all in and all counted, it was Truman who won. And you can find photographs, and I've got one on my Blackboard site, President Truman holding up a newspaper that says, "Dewey defeats Truman." And it was Truman who defeated Dewey. Well, you see, the problem was it was 1948. Most folks didn't have phones. And so by CBS News only calling people, they automatically excluded a large part of the population, and their results were useless. What's interesting is that 4 years later, in 1952, when this new computer called the UNIVAC had been constructed, CBS News used the UNIVAC to predict the outcome of the 1952 election. And it's like, oh wow, check this out. 7%, only 7% of the vote had come in. CBS News plugged this data into the UNIVAC, and the UNIVAC predicted an Eisenhower landslide. And when the final result was in, the computer was only off by 4 electoral votes. Wow. What this showed, A, it showed that computers are really useful. By the way, that's what got businesses interested in the computers. But it also showed something very important for statistics, that it's quality, not quantity, and that a sample, a random sample, carefully selected, doesn't have to be large to give very accurate results. So that's why our samples must be random. When they are, the results are phenomenal. Another example, the Nielsen Corporation, that evaluates television viewing habits, has a small sample of homes across the country. I believe it's less than 2,000. And yet from these homes, from this small sample, they determine the viewing habits of the American population, and what we watch on television is all determined by these few families. So, what are ways we can gather a random sample? Well, one would be called a simple random sample. A simple random sample. And in this, we basically give each person or each member in the population a number, and then we simply select some random numbers, which we can do either with a random number table or with a calculator or in a computer. Simple random sample. Now, a second method would apply, say, in a school, where, say, the principal or the school board or the board of trustees wants to sample the students. So let's say it's a 4-year school, either a high school or a college, and we want our sample to include some freshmen, sophomores, juniors, seniors. So we have 4 levels: freshmen, sophomores, juniors, seniors. We want to include students from all 4 groups. So to ensure that all groups are included, what we would like to do would be to use a stratified sample. So our second type here is a stratified sample. Think of the word strata. Means levels. And so in a stratified sample, we'll be including members from each level of our population. Now, when we do, the proportion from each level in our sample would correspond to the proportion in the population. So say in a high school, 30% of the students are freshmen, then in our sample, 30% of our sample would be taken from the freshmen. And these students selected would, of course, be selected randomly, coming back to a simple random method where they would be given random numbers and selected in that fashion. Another example of a stratified sample, let's suppose United Airlines wants to sample its elite members, and they have silver, gold, premier, and 1K. They have 4 levels of elite or mileage plus status: silver, gold, platinum, and premier 1K. So if they wanted to survey these groups, they could also use a stratified sampling method. Alrighty. A third method applies when, let's say we go to a college or a university, and the college wants to survey its students. Well, you can imagine if you've got several thousand students on a campus, the obstacle involved if you were trying to hunt down individual students obtained from a simple random sample. And in many of our colleges, the lines between freshmen, sophomores, juniors, seniors are often blurred because a level is sometimes dependent on the number of credits a student has earned. So what's another way we might be able to sample college students? Well, every college course has a section number. So what we could do would be to first select some random classes using the class section number, select some random classes, then we would evaluate or survey, if you will, every student in each of those classes. So you've got all these different sections. Select your section numbers and then survey all of the students in each of those sections. That's called a cluster sample. That's our choice number 3. Choice number 3 would be a cluster sample. Cluster sample. Choice 3, cluster sample. So again, we would randomly select all of the classes we want to use. We'd randomly select the sections using section numbers and the simple random method, and then survey all of the students in each of those sections selected. Well, there's a fourth method. There's a fourth method. Let me ask, have you ever gone into the mall and a person said, "Oh, excuse me, we're taking a survey. Could we ask you some questions?" Or maybe they ask the person in front of you and not you and say, hey, what did I do wrong? Well, this is our fourth method, and this is a systematic sample. Systematic. Now, in this method, the understanding is that folks are passing a particular point randomly. So folks entering a mall, walking down a hallway in a mall would be a random process. And we would decide ahead of time, if we're collecting the data, that we will look to survey, say, every 10th person, every 8th person, whatever that happens to be. So if you're coming on down the hallway and I'm number 7, they're going to skip me. And if you're number 8, hey, excuse me, we're taking a survey. Could we ask you some questions? Of course, not everyone will respond. That's part of the sampling process, but that's what's going on in a systematic sampling. Now, an example of what would not be a systematic sampling, let's suppose we go to Newark Airport and we want to survey those folks getting on a United flight to Frankfurt. Well, if we tried to survey people systematically as they board the plane, it would not be random. If you fly United, you know what I'm talking about, because they board by group numbers. So they're going to board Group 1, which would be your Premier 1K, your first class, and then Group 2 would be your business class, and so on down to Group 5. So that would not be a random boarding, and that would not be a systematic sample. So this shows us the difference. I've tried to show you the difference between a population and a sample, how we can select a random sample, and then from that random sample, we gather our data, either qualitative or quantitative, and we analyze that data. I hope it helped.